Hello everybody, I am Hari. Welcome to my class. So today we are going to learn about glycosides. So these glycosides are formed between the hemiacetal or hemiketol OH group of a carbohydrate reacts with OH of another carbohydrate or a non-carbohydrate, then those structures are called glycosides. So here one carbohydrate, it is binding with another carbohydrate or a non-carbohydrate with the help of a bond called glycosidic bond. So this reaction occurs between the OH group which is present on hemiacetal or hemiketol, that is the functional group, OH group that is present on the functional group of a carbohydrate, that reacts with OH group that is present on another carbohydrate or on a non-carbohydrate molecule. It forms glycosides. So the newly formed bond between these two compounds is called a glycosidic bond. So here the carbohydrate means that's fine, we all know. But coming to the non-carbohydrate, which may include methanol, phenol, glycerol or any other non-carbohydrate compound. Okay, so here these non-carbohydrate compounds are called aglycones. Glycone means it's a carbohydrate. Aglycone means it is a non-carbohydrate moiety. Okay. So here the glycosidic bond or the glycosides are formed by the reaction between the OH group that is present on hemiacetal or hemiketol carbon atom of a carbohydrate with the OH group of another carbohydrate or a non-carbohydrate. It leads to the formation of glycosides, and the newly formed bond between these two compounds is called a glycosidic bond. So here we can see two kinds of glycosidic bonds. Those are O-linked glycosidic bond and N-linked glycosidic bonds. Simply we can call O-glycosidic bonds or N-glycosidic bonds. So O-linked glycosidic bond means it is the glycosidic bond is formed between the OH group of a carbohydrate and OH group of another carbohydrate or a non-carbohydrate. Then because the linkage is formed with the help of oxygen, we are calling it as O-linked glycosylation. Coming to N-linked, if one carbohydrate binds with another one or one carbohydrate binds with another non-carbohydrate with the help of nitrogen, like in the case of amines, if that reaction occurs, then that kind of glycosidic bond is called N-linked glycosidic bond. So in case of disaccharides or remaining oligosaccharides or polysaccharides, monosaccharide units are joined with one another by glycosidic linkage. And the next one is the nomenclature of glycosides. So how can we give naming to a particular glycosidic bond? So it depends mainly on the linkages between the two compounds and also status of the ionomer. So based on these two factors, we can name the glycoside, particular kind of the glycosidic bond. So it is nothing but the linkage or the linkages between the two monosaccharide units or between one carbohydrate and another non-carbohydrate, and the status of the ionomer. So here the status of ionomer, alpha ionomer or beta ionomer. So let's know about this with the help of an example, that is the lactose. Lactose is a disaccharide containing two monosaccharide units of beta-D galactose and beta-D glucose. Here these two monosaccharide units are linked with the glycosidic bond. That linkage is 1,4 linkage. So here this is the beta-D glucose, this is beta-D galactose and this is the beta-D glucose. So the first carbon of beta-D galactose, it forms a glycosidic bond, O-linked glycosidic bond with the fourth carbon of beta-D glucose. So here while writing down the name of the glycosidic bond, we write down the first compound, that is beta D galactosyl 1,4, that is from first carbon of this beta D galactose to fourth carbon of beta D glucose. So it is 1 to 4 beta D glucose. So this way, by taking linkage and the state of the anomeric compounds, anomeric carbons, we give the naming to the particular glycosidic bond. So let's know about few physiologically important glycosides. So coming to certain physiologically important glycosides, the first one is a glucovanillin. It's also called vanillin D glucoside. So as we have discussed, we can see one carbohydrate moiety with a glycone, that is a non-carbohydrate compound. So here this carbohydrate moiety is a beta D glucopyranose, which forms O-linked glycosidic bond with ethyl vanillin. So the compound name is ethyl vanillin beta D glucopyranoside. So when we say side, which is nothing but a glycoside, since this compound is a glycoside, we are calling it as pyranoside. Otherwise we simply would have called, if this is the only structure, it is a beta D glucopyranose. Since it is forming a glycosidic bond with this compound, we are finally giving the name pyranoside. Okay, and this is a glucovanillin, is a natural substance and which imparts vanillin flavor to the compound. The next one is a cardiac glycosides, also called steroidal glycosides. So we have many number of cardiac glycosides. So whatever may be the cardiac glycoside, if we observe the structure of the cardiac glycoside, which contains a steroid nucleus, which is a glycone steroid nucleus. It is nothing but the non-carbohydrate compound which has R group at one end, and it forms a O-linked glycosidic bond with a sugar moiety. Digoxin and digitoxin, these two are very important cardiac glycosides and they contain the same structure like cardiac glycosides, and they are very important because they stimulate muscle contraction. Let's see the remaining things. So coming to the next example of physiologically important glycosides, that is streptomycin. So streptomycin, it's an antibiotic that is used in the treatment of tuberculosis. So if we look at the structure of streptomycin, which contains a streptoline moiety, which is a cyclic structure with guanidine groups at first and third positions, and it forms a glycosidic linkage with two monosaccharide units, that is a disaccharide unit at fourth position. So those two monosaccharide units include the modified form of beta D lixifuranose and the modified form of alpha D glucopyranose. So this is the structure, and here this is the O-linked glycosidic bond that we can see in streptomycin. So coming to ovabane, which contains a 5-membered lactone ring which binds with a steroid nucleus, and this steroid nucleus which forms O-linked glycosylation with a carbohydrate. So here the carbohydrate is a rhamnose. This is the structure of glycoside, that is ovabane. Okay, and coming to its importance, ovabane, which inhibits sodium potassium ATPase pump and thus which blocks the active transport of sodium. So all these are the examples of few physiologically important glycosides. And the next one is the monosaccharides are reducing agents. So monosaccharides, they can be oxidized with oxidizing agents like ferric ion or cupric ion. So with any of these oxidizing agents, the monosaccharides can be oxidized. So because of this, the carbonyl carbon, that is the aldehyde group that is present in monosaccharides, will be converted to carboxylic group. The aldehyde that is present in these monosaccharides can be converted to carboxylic group with this reaction. Okay. So monosaccharides can be oxidized with the oxidizing agents, mild oxidizing agents like ferric ion or cupric ion, and because of this reaction, the aldehyde group that is present in the monosaccharide will be converted to carboxylic group. So the glucose and other monosaccharides which are capable of reducing these ferric ion or cupric ions, those are called reducing sugars. This is the ring structure of beta D glucose. which can be converted to its open chain structure, as we have discussed in the meta-rotation. So if we observe the equilibrium mixture, we know that around 99% of a mixture contains only the ring structure, and less than 1% of the mixture contains open chain structure. So this open chain form of beta-D glucose, which can readily undergo the reaction with oxidizing agents like ferric ion or cupric ion, because here the aldehyde group is freely available, which is freely available to react with the oxidizing agents. So here aldehyde group will be converted to carboxylic group. So those sugars that are readily reacting with oxidizing agents are called reducing sugars. So the sugars which can readily undergo reaction with oxidizing agents are called reducing sugars. Coming to this case, here beta-D glucopyranose, it reacts with methanol. So CH3OH, methanol in acidic conditions. So now this methanol reacts with the carbonyl carbon, that is the oxygen of this OH. It forms a linkage with this carbon. Okay, so the first carbon of glucose and the oxygen of OH group in the methanol, they form the linkage. So that linkage is called O-glycosidic linkage. Hope you all understood. Here the beta-D glucose, it reacts with methanol in the acidic conditions and it forms two methyl derivatives or methyl glycopyranosides. So those two are beta-D glucopyranoside and alpha-D glucopyranoside. So here the new bond is formed between the carbonyl carbon and the oxygen of OH group that is present in the methanol. So this linkage is nothing but the O-glycosidic bond. So those two derivatives, those two products are beta-D, methyl beta-D glucopyranoside and methyl alpha-D glucopyranoside. Unlike open chain structures of beta-D glucose, these methyl derivatives or methyl glycosides cannot be readily undergone the reaction with oxidizing agents, because here in this case the aldehyde group is not free to get converted to its open chain structure. Here this can be interconverted to open chain structure because here the aldehyde group is free. But coming to here, which is not free, which is already reacted with a methyl derivative, so it formed a glycosidic linkage. So glycosides cannot be readily undergone the reaction with oxidizing agents like open chain structures. So those structures which are not readily undergoing the reaction with oxidizing agents, those are called non-reducing sugars. So open chain structures, since the aldehyde group is free, they can be readily undergone the reaction with oxidizing agents. So those are called reducing sugars. But the glycosides of glucose, they cannot be readily undergone the they cannot be readily undergone the reaction with oxidizing agents because the aldehyde group is not free to be converted to its open chain structure. So they cannot undergo the reaction. So those that are unable to undergo the reaction with oxidizing agents, those sugars are called non-reducing sugars. So hope you all understood. If you have any questions, please mention them in the comment section. Thank you.